Hi everyone. Apply the gradient descent in logistic regression step by step for the given data set which is having samples 1 and 2. Here M is 2. Then actual output is for sample number 1 is S, which is encoded as a 1, and this no is encoded as a 0, which is briefly explained in the previous video. If you can't understand this, please watch the previous video. Here when you are applying the sigmoid function for the sample number 1, you are getting the 0.871, which is transforming into the 1 as per sigmoid activation function. Sample number 2, which is also predicted as a 1. So actual output 1 for the predicted sample number 1, and predicted output is also 1, so correctly classified. Sample number 2, actual output is 0, predicted output is 1, wrongly classified. Because of wrongly classified, when you are calculating the cost function, when you are substituting the values of actual output and predicted output given in this table, you will get 50% of error, that is 0.5 is the cost function. Since it is wrongly classified, the entire data set, we have to apply the gradient descent to minimize the error. The gradient descent will use the convergence theorem to update the parameter theta values. So here we are having the g equal to theta 0 plus theta 1 and x1. So we have to update the theta 0 and theta 1 uh, to minimize the error for given statement. So here theta 0 is given, theta 1 is also given. Here x0 is always 1. Okay, so based upon that, learning rate is also given 0.01. Now we will apply the convergence theorem. Here new theta 0 will be updated by using old theta 0 minus alpha into partial differentiation with respect to theta 0 of j theta. So here the equation is given based upon the mini batch stochastic gradient. Okay, this is the mini batch stochastic gradient approach. So now we are substituting the values for two samples. Here we are having this is the predicted output of sample number 1 minus predicted actual output of sample number 1, and x0 for the sample number 1, and added with predicted output of sample number 2 minus actual output of sample number 2, multiplied with this x0 for the sample number 1. So this is sample number 1, x0 for the 1. Now we are substituting the values. Here alpha is given 0.01, and here 1 by 2 m is the number of samples. Here we are having 2. Then this is the predicted output of the sample number 1. Here predicted output is given here, then actual output is 1, so given into x0 is always 1. Okay, x0 is always 1. Then plus actual output of the predicted output of the sample number 2 y2 dash, this one, minus predicted actual output of the sample number 2 is 0, then multiply with x0 value. So when you are simplifying this term, you will get finally this 0.005 for this term, and 1 minus this value, you are getting 0.995. So this is the new theta 0 value. Now we are going to calculate for the new theta 1 value, old theta 1 minus alpha into partial differentiation with respect to theta 1. So we are substituting the values. Old theta 1 is here 0.5, which is given here, and minus learning rate 0.01, which is given, and 1 by 2 number of samples. This is the predicted output of the sample number 2 1, and here sample number 1, this one, first one, and predicted output of the sample number 1 is 1, and actual output is also 1, multiply with x1. So x1 is here 1 for the sample number 1, plus 1 minus 0, this is predicted output for the sample number 2, and minus actual output of the sample number 2 0, then x1 for the sample number 2. So when you are simplifying these values, you are getting the 0.01, finally you are getting the 0.49 as the new theta 1. So we got updated value. Previously theta 0 is here 1, theta 1 is here 0.5. Now you look at that, we updated the parameter values by using the convergence theorem, that is stochastic, gradient descent algorithm. So our error is in the iteration number 1 you assume here. Now we have updated the theta value. We are going to apply this updated theta value into the sigmoid function in the iteration number 2. In the iteration number 2, we are going to use new values of the theta 0 and theta 1 we got in the previous step. When you are applying the G1, you are getting the 1.49, G2 is 1.98. When you are applying the sigmoid on the G1, you are getting 0.816, G2 0.878. So sample number 1 again predicted as a 1, and sample number 2 also predicted as a 1. Still, when you are calculating the cost function, actual output into log of predicted output 1 minus actual output into log of 1 minus predicted output, when you are substituting the values, you will get finally 0.5. Again we are classifying this second sample is misclassified, first sample is correctly classified, so again 50% of error. Then here again we have to apply the gradient descent to minimize the error. Now again applying the convergence theorem for the iteration number 2. Here we are having the theta 1 and theta 0. Yes, updated theta 0 is 0.995, theta 1 is 0.49, and x0 is already given 1. So here our equation G is here theta 0 plus theta 1 x1. So we have to update the theta 0 and theta 1. Now as per the convergence theorem, we are going to give the old theta 0 value 0.995 at the iteration number 1. Now we are going to do the 0.01 as alpha value, number of samples. This is the predicted value for the sample number 1 and actual output of the sample number 1. So now multiply with x0 values already given for the sample number 1, and predicted value for the sample number 2, 1, and actual output for the sample number 2 is 0. Then x0 for the sample number 2, x0 for all the samples is 1 only, so which is given. Now when you are applying the values based upon the given calculation, we are getting 0.005. So as per this formula, when you are subtracting, you are updating the parameter value theta 0 as a 0.99. You see slightly it is updated. Previously it was 0.995, earlier than that it was 1. So now it is updated with gradient descent. Now theta 1 is also again we are going to update for the sample number 1, x1 value here, sample number 2, x1 value here. This is actually sample number. Okay, now we are substituting the values, predicted value and actual value for the sample number 1, which is given here, and predicted value and actual value for the sample number 2, x1 is here 2. When you are simplifying the term, you are getting 0.48. So previously it was 0.49. So now our error is parameters are updated in the second iteration in this one. So like that we have to repeat until we are getting 100% or close to the 100% of accuracy. So when it will reach, when you are getting the minimum error, so you have to keep on apply this steps until getting the cost value is close to the 0. So this is the way to compute the gradients for each and every problem given in the logistic regression classification.